If your .NET microservice is slow, it's often not the database. It's the way you are using Entity Framework Core. And the worst part, the service may look fine under low traffic until it collapses under load. So today we are going to talk about Entity Framework Core performance. And the first of all is, this is performance only, okay? This is Entity Framework performance only, no basics. I'm going to cover exact parts that we use in production. Some things like the use of the famous AsNoTracking, the projections versus entity materialization, the query constructions for searchability, filters, and pagination, and the core performance rules I follow. So, why Entity Framework Core gets slow in the APIs? Think about it. Entity Framework Core becomes slow when we accidentally do one of these three things. We track entities we don't need. We materialize big graph of data we never use. And we move work from SQL into memory. Remember that. Why the Entity Framework Core in the performance testing is slow could be because of that. Because of the tracking of entities we do not use and we do not need. We materialize a lot of things that we are not going to use, and we translate all the SQL into memory. Those three things could create or can create CPU overhead, memory pressure, and latency spike. So, talking about the first one, the first thing I said before of the practices that we could follow, the first one was the use of the method of AsNoTracking. Okay. First, tracking versus no tracking. I use AsNoTracking by default when we are not going to modify entities. Check this out. We use AsNoTracking when we are not going to modify the entities. Tracking adds overhead because Entity Framework maintains snapshots and a change tracker. So if we are working with, hey, give me the users, and we update one of those and one row and two fields and so on, Entity Framework maintains snapshots and a change tracker. So that cost CPU, memory, and additional work per entity. So the rule is simple. If it's a read and I am not updating entities, we use no tracking. If we read and we do not update, we not track. Okay? This one change alone can dramatically reduce overhead in high-read APIs. Second, projections versus materializing entities. In API-oriented reads, we prioritize projecting directly to DTOs from the query, like for example, select new, instead of doing a full fetch of the entity. Select new, okay? This avoids materializing large graphs. This avoids excessive includes usage, and this avoids overfetching data you don't need. It also reduces the allocations and improves overall query time. Causal effect. Less data materialized means fewer allocations. Fewer allocations means less garbage collector pressure, and that means better latency under load. Third, query constructions, searchability, filters, and pagination. Okay? Our goal is that everything is executed in SQL and is searchable, for example, if that's the case. So we could follow the rules of filter first, avoid index breaking patterns, pagination with consistency ordering, and we do not load everything into memory. And that means, for example, we filter first, we reduce rows early, we do not bring back a huge data set and filter later. Okay, that's not like, hey, give me all and then filter. No, we filter first. We avoid functions in columns in where clauses that break in index usage, so we can use correctly use indexes. We use pagination with skip take, but we always consider consistent ordering. No stable ordering means unstable pages, duplicates, or missing records. And about loading everything in memory, we don't want that. We avoid loading everything into memory and filtering afterwards. That's one of the fastest ways to kill performance in service under traffic. So the theme is always the same. SQL should do the work, not the application memory. SQL should do the work, not the application memory. Okay? Fourth, what is the value we can provide here? The performance rules were these. For reads, we use AsNoTracking. For API responses, we project into DTOs. We avoid include unless absolutely necessary. We avoid to list early. We keep it as equerable until the end. Okay, we populate and we use equerable until the end. And finally, we use the to list. We do not mix in-memory evaluation with database execution. We are very carefully with methods entity frameworks cannot translate. And finally, we separate what is read queries from write commands like CQRS style. The combination keeps query lean, predictable, and scalable with these rules I just said. So, if we apply those rules, we could have, for example, lower CPU usages, lower memory usages, fewer latency spikes, better throughput, and fewer production surprises. Because we stop reading accidentally expensive things. Okay? So, finally, tracking. Tracking is hidden overhead. Okay? If we track, we are hidden overhead. We are doing hidden overhead. We project to details. We do not materialize graphs. We filter first. SQL must do the work, not the application memory. We filter first. First, we do not want our application to do all the work, and the pagination needs to be stable ordering. Okay, and we avoid to-do list to the end. So if we track, we do not use AsNoTracking. If we no track, we use el AsNoTracking. Okay. Second, we project to DTOs. We do not bring everything. We do not materialize graphs. We filter first. The SQL must do the work, and that's it. I hope it's good for you, that this helps, and see you next time.